All right, we're off to the races. Um, so we've been already talking about functions as something where you kind of have an equation and you're given x values, an input, right? That you're plugging into the equation, you're doing some math stuff, and then it spits out the y value. And so, like with these linear equations that we just worked with, technically those are called linear functions. Okay, and throughout the entire semester, the entire 8-week course, we're going to be talking about different types of functions. But first, we need to formally define them the way mathematicians think about functions. And so we kind of have to back up and talk about what is a relation. So we have some objectives here. We want to define some new terms, define what a relation is so that we can better understand the formal definition of a function. Then I'm going to have some practice problems in this lecture so that I can see if you guys can apply that definition and identify whether something is a function or not. Okay. Then we'll talk a little bit about x-intercepts and y-intercepts. Kind of going to breeze through that. If we have time, we'll talk about domain and range. But you guys are going to get plenty of practice in the homework to identify the domain and range of different functions. So let's start at the beginning. Okay. What is a relation? It's a very simple definition. A relation is just a set of ordered pairs. Okay. So if I have multiple ordered pairs, we're going to call that a relation. You guys already know from the last PowerPoint that the set of all the x values in a table is called the domain, right? So really, the set of all x values in a relation is called the domain. So if we have a bunch of ordered pairs and I just look at all of the x values and list them, that's the domain. Similarly, if I just listed all the y values from that set of ordered pairs, that would be called the range, okay? So you can think about a relation as connecting two pieces of information. Something from the domain, something that we call an x value, is linked to something else in the range, which we tend to call a y value. So there's a connection that's being mapped from the domain to the range. Okay. And just to visualize this, um, I have this like simple example. A lot of students that take this class at St. Philip's are nursing students or maybe pre-professional that are going to be eventually working in a hospital type setting. And so the nice thing about math is that it doesn't, students tend to think it's all about numbers and calculating stuff, but really it's about understanding the relationship between two different variables and sometimes more variables. So let's think about this example and take a step back, okay? Imagine that I work at a hospital and I'm looking at a patient database. And in that patient database, I have the set of patient names. So set A contains my patients, Bert, Maddie, Lisa, DeAndre, and Esmeralda. Okay. Well, in a hospital, you usually want to know what people's health conditions are. So we have these patients, and we might say, okay, that's going to be our domain. But we want to think about another set, which is what are the different kinds of health statuses that they might have, right? We might have patients that are healthy, some that are diabetic, some that are anemic, some that have tachycardia, right? So we have a second set of information. It's not patient names, it's health conditions or health status. And in the patient database, you want to know what patient has which condition. So you want to be able to link that information together. Okay. So visually, what we might do if we were just to draw like a diagram, we might say, well, okay, maybe Bert is tachycardic. So I'm just going to draw an arrow between these two maps, right? From the domain to the range, I have this linkage. Bert is tachycardic. Maddie is healthy. So I draw an arrow connecting them. Lisa is anemic, so I have an arrow between them. DeAndre is tachycardic, got an arrow between them. And then Esmeralda is diabetic. Okay. Now you might not realize it, but each of these linkages connect an X value to a Y value, and they didn't have to be numbers. So for instance, if I look at the first element in my domain, Bert, I'm just going to put, yeah, I'll write Bert here. I can make an ordered pair that's Bert as my X value, And then his condition is tachycardic. So I'm just going to put tachy because I'm a little bit lazy and I don't want to write the whole word out. And plus, you guys don't want to see my terrible handwriting. But I have an ordered pair. Bert is the X value, tachycardic is the Y value. And so this diagram, even though it doesn't really look like it, it is actually the same as a set of ordered pairs. So this is a visualization of a relation. Okay. So if you wanted to see that this relation as a set of ordered pairs, it kind of looks a bit messier, but this is the exact same information, the patient database information that we just looked at, but written as a set of ordered pairs. Okay. Notice that for a set of mathematical objects, in this case ordered pairs, we have a bunch of XY pairs here, where X is the patient name and Y is their health status. Notice that we have the brace, a set of braces that encloses the entire set of ordered pairs. But this has the same information as that diagram that we have from the previous slide. We have Bert is tachycardic. We have Maddie is healthy. Lisa anemic, and so on and so forth. Okay. So again, we're just trying to get down this idea that a relation is just a set of ordered pairs. Okay. So if that definition is simple enough, then we can start to talk about what a function is. And function is actually a type of relation that has a very specific definition. And we want to be very careful with how we approach this because I'm going to ask you to read this definition and then tell me whether the relation that I show you satisfies the definition. In other words, is this relation a function? Okay, does it meet the requirements to be called a function? So here's the definition of a function. A function is a special type of relation or a set of ordered pairs in which each element of the domain is mapped to exactly one element in the range. We often say y is a function of x, but all I'm really going to ask you here is if you look at this example that we've been playing around with of patients and their health status, we know it's a relation. That's given. But does this satisfy the definition of function? I'm going to give you guys a moment to think about that. Maybe reread that definition. Is this a function? And go ahead and put your answer in the chat. If you have a wild guess, go ahead and do that. And if you don't know, you can also put, I don't know. I need more information. Okay, we got our first victim or our first courageous volunteer here. Lynn is saying, yes, this is a function. Sky is saying, this is a function. Audra is saying, no. Okay, any others? So it looks like we mostly have yes. Okay, let's think about this for a moment. Audra and Anna, you guys are saying no.
Yes.
Why do you think that this is not a function?
I was thinking because the Bert and
Bert
DeAndre
and DeAndre
both tachycardic, so
are
there's
both tachycardic.
repetition.
Ah, okay. Now that's a good observation, right? Everybody noticed that Bert is mapped to tachycardia and DeAndre is also mapped to tachycardia. Okay. So on first glance, if we just look at this definition and we just read it, it says a function is a relation where each element of the domain, right, those would be the patient names, are mapped to exactly one element in the range. Okay. So I could see why you would think that this is not a function. But I like to use a sort of an analogy to make sense of this because here's the thing, mathematicians are very precise, they're very literal with their definitions. And sometimes when we read a definition, or if somebody tells us something, sometimes we project into the definition something that's not there. But we want to treat this like we're lawyers, right? And sometimes lawyers, they are very literal to the language of the law. Okay. This definition says each element of the domain is mapped to exactly one element in the
Oh,
range, right? So let's look at each element in the domain. Bert, how many things is it mapped to in the range? Let's count them. Well, Bert's mapped to tachycardia, right?
yeah. I
So
see.
Bert has one mapping. Maddie is mapped to healthy. So how many things is Maddie mapped to?
Just the one.
Just the one. You see where I'm going with this?
Yes.
Lisa's only mapped to one thing. DeAndre is mapped to one thing. Esmeralda is mapped to one thing, right? Because they only have one arrow leaving them. So the definition is only restricting how many things the elements in the domain, the X values, can be mapped to.
Okay.
It doesn't restrict the elements of the range to only have one thing mapped to them. Okay. And I have a funny analogy that might like make this concept stick, even though I'm sure that you have it right now. Okay. And that is, think about it this way. In Western society, certainly in the United States, most people, well, nowadays things are a little bit more fluid, but for most of us, like the average experience of an American, you guys are used to like people in relationships being monogamous, strictly monogamous, that if they're married, you have a husband and a wife, and they have to be faithful to each other, right? But think about this definition as saying the elements in the domain are like the husbands. I'm just going to put hubby right here, right? So the definition says that the husbands need to be mapped to exactly one element in the range. Okay, well, that means that the husbands must be faithful to their wives. I'm going to put wifey here. Okay. But the definition doesn't say that the wives have to be faithful to their husbands, right? So it doesn't matter that this particular wife is running around on husband Bert, right? Because this definition only restricts the behavior of the husbands. The husbands have to be faithful. We don't care what the wives are doing.
Okay.
Does that make sense?
Yes. That's a
Okay.
fun play on it.
Yeah, yeah. And so like later on in this summer course, we're going to be talking about another special type of function called a one-to-one function, where we will restrict the behavior of both the husbands and the wives so that they are perfectly faithful to each other. Okay. But for now, the definition of the function only restricts the behavior of the quote unquote husbands.
Okay. Thank you.
Okay. All right. So that being said, I like to play this game that I call function or not. Okay? Where I give you guys a set of ordered pairs and you tell me, does this set of relations or this relation, this set of ordered pairs, is it a function? So here we have the relation A. A is equal to the collection of ordered pairs 3 comma 1, 2 comma 5, negative 4 comma 2, negative 1 comma 0, and 3 comma negative 4. Is that a function? Take a minute, put it in the chat. Excuse me, put it in the chat if you're feeling confident about making a choice. Excuse me. I'm seeing that. Yes, yes, BRB. Yes. Yes. Okay, let's take a look. You're saying that it is a function. Well, let's take a moment and just draw a diagram, right? If I ask you guys, here's my domain, which is the set of the x values. Can you tell me what all are the x values that go in the domain?
3,
3,
2.
2, -4, -1. It's not a function because there's another 3. Is
So,
that
so that's exactly right. Once we have a repetition there of the x values, well, it doesn't necessarily mean that it's not a function, but we start to raise our eyebrow there if we have a repetition of an x value, okay? Now, when we're writing the domain, we don't have to write that number 3 twice. We're just going to write it once, and then we can move on to the range. So let's just go ahead and finish this little drawing that we're going to make, okay? What are the numbers in the range?
1520.
1520, and
Negative.
also negative
Negative
4,
4.
right? And so if we wanted to, you guys should be able to draw a mapping or a diagram. So if this is a function, that means that every one of the elements over here in the domain, the x values, should only have one arrow connecting them to something in the range. So based on the ordered pairs, 3 is mapped to 1, 2 is mapped to 5, negative 4 is mapped to 2, negative 1 is mapped to 0, and then 3 is mapped to negative 4 again. So is this a function?
Yes.
Hold on. Is it a function?
No,
No.
Why is it not a function?
because the 3 is
There's
with,
an extra set in the Y.
yeah.
So,
Have a
if you want to go back to that analogy I just used, this husband is not allowed to have two wives, and it does, right? So it violated the definition of a function. Does that make sense that this is not a function?
Yes.
Yes.
Okay. So we can't have that husband having more than one wife. Okay. So anytime you look at a set of ordered pairs and you have something that has the same x value, well, they better have the same y value. Otherwise, if it's running around with two different wives, automatically not a function. Does that make sense?
So why didn't that pertain to the previous
The
where you
previous example,
we had the names?
let's go back and look at that.
Because
Right.
there was two tachycardics.
Uh-huh. Yeah, but let's be very clear about there's two of what, right? The definition of function,
Oh, okay, because there's two people that have the same.
the two people have the same wife, but we don't care about what the husbands, I'm sorry, we don't care about how many husbands the wives have. We just want to make sure that no husbands have more than one wife. Okay? So think about it this way. Like Bert couldn't be tachycardic and healthy, right? You're either one or the other. So as long as each of the elements of the domain, each of the x values only has one arrow leaving it, then that's fine. But as we saw with the example that we saw on the next slide, right, the first one, we have this scenario where we have 3 comma 1. So the number 3 is mapped to 1, and it's also mapped to negative 4, and that's not going to be allowed. You cannot have one husband that has two wives.
So is X being considered the husband?
X are the husbands, yes.
Okay,
Yes.
got it.
Okay, so let's look at this example. Is this relation, does it satisfy the definition of a function? And feel free to draw the mapping, right? Those bubble maps where you have the domain on one side, the range on the other, and then draw the arrow to connect them. Is this relation a function? Get some action in the chat.
Yes.
Yeah, right? So if we look at the elements in the domain, we have negative 1, 2, 3, and negative 4. Then we can look at the elements in the range, which are 4, 3, we have 4 again, and then we have 5. So like one thing I might note is the number of elements in the domain and the number of elements in the range, they don't have to be the same number. It doesn't have to be the same number of elements. But when we look at these mappings, we look at the ordered pairs, 1 maps to 4, 2 maps to 3, 3 maps to, what does 3 map to? 4. There we go. And then negative 4 maps to 5, right? So we're just concerned about the husbands, and this husband has one wife, this husband has one wife, this husband has one wife, and this husband has one wife. So this is a function. And I'm just abbreviating function as f of x, okay? All right, let's take a look at another example to see if this kind of hits home now. We have this set of ordered pairs, which is q comma 1, r comma 1, s comma 1, and t comma 1. Is this a function?
Yes.
Yeah, definitely. Okay. And if you needed to draw that bubble map, you can see that we have this set of elements in the domain. So I'll call that my x. I have q, r, s, and t. And then I only have one element in my range. It does not matter that my range only has one thing in it, but this husband is faithful to this wife. So that husband only has one wife. This husband only has one wife. This husband only has one wife. And this husband only has one wife. Okay? Again, you really got to fight yourself if that's a struggle for you to try to force the wife into doing anything because the definition doesn't place any restrictions on her. It does not matter that she has, in this example, 4 husbands. What matters is what the husbands are doing. Does that make sense?
Yes.
Okay. Cool. So you're going to get a set of problems in the homework that ask you to determine whether something is a function or not. All right. And then it's going to give you some graphs, and you need to have a tool to determine whether or not this graph or any other graph that they show you, if that represents a function. Okay. So if they say, here's the relation, here's the graph, how can we determine that it's a function? Well, we have a different tool for doing this, but really it's the same idea. So let's look at this example. And just for clarity's sake, I want to make sure you guys understand when I say graph, I'm not talking about the x-axis and the y-axis. Those axes are just there so that we can help locate ourselves in space and figure out where the points of the graph are located, okay? But here we have to focus on the blue line. That's going to be our graph. Let's call that R because that's our relation, okay? So we have this blue line that's kind of curvy like this, and we want to determine whether or not that's a function. So we're going to apply something called the vertical line test, which essentially means we should be able to drop a vertical line anywhere on the graph, and if any of those vertical lines have more than one intersection with the graph, then it fails the vertical line test and it's not a function, okay? So why does that work? Well, one, think about any vertical line that we draw as representing an x value. So for instance, the vertical line that's already there is passing through which x value? Right? This vertical line represents the x value equal to 2. Okay? And at the points where that graph intersects the blue line, we have an intersection point there. We could say that, you know, this point, maybe it's not a really nice, pretty point, but it has an x value of 2, and maybe it has a y value of something a little bit over 2, right? It's like maybe 2.25. Okay, so for this example, we're going to be a little bit imprecise, and I'm just going to say the y value here is 2.25. Okay, so like if I go up from this x value and I get to this location where that intersection's happening, then over here we have a y value that's a little bit above 2. Okay, but that x value also has an intersection point down here, right? And that point can be represented as 2, comma, and then the y value is something a little bit less than negative 2. So let's say that's negative 2.25. Okay. Well, the vertical line test is basically checking to see if there's any x values that are mapped to more than one y value. And if it is, then it can't be a function because it violates the definition. So what we have right now is the x value x equals 2, and that's mapped to a y value of 2.25 and another y value of negative 2.25. So you cannot have more than two y values for any one x value. So that's why we can use this to say that this is not a function. Okay. Maybe that's a little bit convoluted. Once we get into some practice here, you'll see what I mean by that. And so let's just jump into some practice. Here's a graph. We have our x-axis, we have our y-axis, but we really want to focus on this kind of U-shaped curve. Okay. So what I'm saying is that if this is a function, anytime I draw a vertical line through the graph, I should only intersect the graph one time. Okay. So what you might do is, grab your pencil and put it up to the screen, or you might say, let me take this tool from Zoom, and I'm going to put a vertical line right here. So this pink vertical line that I just drew on the graph, how many places did it intersect my graph?
Just one.
Just one. So I should be able to do that for any vertical line. So I'm going to put another vertical line here. How many places did that vertical line intersect my graph?
One.
And if I keep doing this throughout the entire graph, just putting vertical lines, do I have just one intersection there?
Yes.
Yes.
Yeah. I can keep dropping vertical lines, and every vertical line only has one intersection. Right? So for each of these vertical lines, remember, they represent x values, and the intersection point tells you that there's a y value associated with them. And since they only have one intersection, these husbands only have one y. Okay? So this is a function. Does that make sense?
Yes.
Yes.
Okay. So then I'm going to let you guys take the reins on this next one. Even though this other graph over here on the right is kind of broken into two parts, this is called a piecewise function because it has multiple parts, but technically it's the same graph. It's one graph. Can you tell me, does this pass the vertical line test or does it fail the vertical line test?
Fails,
Why does it fail the vertical line
I would
test?
say fail to.
because there's no intersection.
Okay, so remember, we're looking to see if we can draw a vertical line. How many intersections does my vertical line have with the graph?
One,
Okay, I can draw a vertical line here.
Mhm.
How many intersections?
One.
One.
So we're looking good there. I can draw a vertical line over here. How many intersections do I have?
One.
One.
And I can keep going, and I can keep going. And how many intersections does any of these lines have?
One.
Okay. But did I skip past something that's probably important?
Yes, you did.
the 2 points.
The points.
The points here that align with the x value of -2, right?
And there's two. Mhm.
That vertical line at -2 has two y values. It has a y value of 4 and it has a y value of 2. So just because this is broken up into two pieces doesn't mean that you get to violate that definition. So once I drew that vertical line passing through those two solid points, I immediately violated the definition of a function. So this one is not a function. Questions, comments there? Okay. All right. You're going to get more practice with that in the homework. So if it's not like fully clicking right now, or if you're finding it a little bit hard to follow, I think that some people have more experience reasoning with spatial objects. Like if I told you to take a piece of paper and then fold it a certain way, some people can imagine that a little bit better in their heads. When I was in high school, I took a lot of art classes, visual art classes, so I can draw things very well. I'm also very experienced with drawing graphs, so I can see them, right? But if this is your first experience or you've been out of school for a while, it can feel kind of frustrating because you don't know exactly what you're looking at. So you're going to get that practice in the homework, but just make sure if you are struggling that you send me a message and a screenshot to say like, hey, I don't know what I'm supposed to be looking at here. Can you give me some pointers? Okay. And I'll be happy to do that. So just make sure you're asking for help if you need it. So we're going to continue talking about functions. And up to this point, we've talked about functions as ordered pairs that satisfy that definition where the husbands must only have one wife. We have talked about functions in terms of graphs now, and we've already been using functions in terms of equations, right? So we've seen this notation already, f parentheses x equals y, because a function is something that has a name, okay? The f part isn't something that we're multiplying by x, it's just the name of the function. Mathematicians are really lazy, so they get tired of writing a function of x equals y, so they just abbreviate it to f parentheses x equals y, okay? So f literally just means function, okay? The y in this notation is going to be a number in the range, which we can usually get by just looking at a set of ordered pairs or looking at a graph or plugging something into an equation and then doing something in our calculator and it spits out the y value, okay? So I want you to think about it this way. And I may have mentioned this analogy in the past, but I like to think about a function as you're dropping in a quarter into the jukebox. So this is like your input. And then the jukebox will play the song, and this y value is the output. Right? That might seem confusing or convoluted, but like you guys deal with machines in your life all the time. Think about like a washer and a dryer. A washing machine takes certain inputs, right? Like it takes dirty clothes, right? And the output of the washer is wet, clean clothes, right? So you put something into something, it does some work, and then it spits out the output. And so like that's how we need to be thinking about these functions, that they're machines that do work, but the work that we're specifically talking about here is usually going to help us find some other number, okay? So for now, you just really have to be clear that in other parts of math, whenever we had parentheses, it meant multiply. But in the context of functions, it does not. Okay, that f of x is just telling you what to plug into the function, and then we're going to do some work with an equation later to figure out what the y value is. Okay, so these two slides just basically say the same information, so I hope you don't mind me just skipping over this one. Let's get some practice getting back into the swing of evaluating functions because we did that on Tuesday, right? We said, let's say we have this function g of x, and it equals this weird looking equation that's a fraction, right? It's 3x squared plus 2 all over 7, okay? I don't want you to be like too intimidated or invested in this thing. You don't have to be afraid of it. We're just going to use it, okay? So you've seen some homework questions that say, find g of 0, okay? What you should be doing whenever you see a problem like this is telling yourself, reminding yourself maybe, that what is this x value? Well, it's just your, what is this number? It's just your x value, right? I got ahead of myself there a little bit. Okay. So whatever number is inside the parentheses, that's your x value, right? The other side of the equation has something complicated, some expression that we need to evaluate. But what do you think we're going to do with this x value? What have we been?
Plug it in.
Yeah, the same thing that we've been doing up to this point, right? We're going to plug it in and replace the x here, okay? So what you guys should be doing is saying, okay, g of 0 is simply equal to 3 times something squared plus 2 over 7, right? And then you have to remember, well, what am I plugging in for x? Well, that's the 0 that they gave us. Okay, so what do I do next? Any ideas?
You saw the top row? you put it in your calculator.
You put it in your calculator. You put it in your calculator. The whole thing. Okay. So what I want to do is let me write this down really quick on paper and I'll switch over to the document camera to see how this will work, right? So that you can also see the calculator. 3 times 0 squared plus 2 all over 7. And guys, I said this yesterday and I'm going to keep on saying it. You need to make your calculator your best friend. And the reason why is because of this. Let's see if this works. A, that's flipped upside down. And I lost my document camera. Let's see if I can get it back. Nope, that's the wrong camera. Camera number 2, camera number 3, camera number 2. Okay, let's see if we can find this document camera. Think we're gonna get it. I have faith. Okay, bear with me for a moment. There it is. Okay, so let me see. It should work now. There we go. Can you guys see that okay?
Yes.
3 parentheses 0 squared plus 2 over 7. All right, how are we going to put this in the calculator? Guys, remember yesterday I said if we want a fancy fraction, we can just hit alpha y equals enter. Once we have that fancy fraction, we will type this exactly into the calculator the way we wrote it down. So I'm going to put 3 parentheses 0 squared plus 2. There's my numerator. Divided by 7, right? Exactly the way I wrote it down. Maybe I don't want to jostle my document camera too much, but exactly what I wrote down. Then hit enter. That's the answer, 2 over 7. Questions?
Yes, type in that problem again on the
Yeah.
calculator.
Yeah, okay. So to get a fancy fraction, you're going to hit this green button, alpha.
Okay.
Okay. Then you're going to move up to this y equals button. That's going to give you your fraction options.
Okay.
Then you're going to hit enter. And so now you should be seeing this fraction that we're going to be able to manipulate on the calculator.
Okay. Okay.
So now we're just going to type 3 parentheses 0 close parentheses. Then we have the square button over here. If you want to use the square button,
Mm-hmm.
square that. And then we're going to put plus 2.
Okay, that square button.
Okay, then we're going to just use this down arrow key to go down into the denominator, and we can put that denominator of 7 and then hit enter.
I got it. Thank you.
Okay. Yeah, of course. So 2 over 7 is our output value. And let me zoom out. Hopefully I don't jostle it. There we go. All right. So what we were looking for was g of 0. Okay. So really, you should know you have this x value that we plugged in. X is equal to 0. And then the output value, that final answer that we got, this is what we call our y value. Y is equal to 2 comma 7. So if you wanted to start graphing this function to know what it looks like, you would write that ordered pair as 0 comma 2 over 7. Okay. All right. Let's see. I lost you guys. All right. So if we wanted to continue, we could do things like evaluate this function at other x values. So if I ask you guys to evaluate g of 1, what would we do here? What would I need to write down?
3 parentheses 1 to the
To the second power, yeah.
power plus 2 divided by 7.
That's exactly right. And then we can evaluate that in the calculator, right? So one other nice thing about the calculator is that if you wanted to, you could just go up twice to highlight what you just typed in. And if you hit enter, it copies it. That way, we could just use these arrow keys to go back up to the numerator. And if we highlight over the 0, we can just type a 1 and that overwrites it. So now we have 3 times 1 squared plus 2 all over 7, which is exactly what we wrote down. Hit enter. And then that's your answer for this one. So we have 5 over 7. Are you guys okay with that? Any questions, comments?
No.
Okay. So in that problem, we plugged in an x value of 1 and we got out a y value of 5 over 7. So what's the ordered pair that comes from this problem that we just did?
0,
Zero.
1, 5, 7.
1, 5, 7, right? So think about these functions as being machines where you plug in their x values, they spit out the y values, so they generate these ordered pairs, right? And since a function is a relation, it should be something that generates ordered pairs, okay? So anytime we need to graph a function, we just need to put in some x values, it'll spit out the y values, we'll have the ordered pairs, and then if we needed to graph this, we could graph this, okay? All right. One other thing that you guys have to be aware of, because I think there is a problem in the homework that's a little bit more complicated than this. So let me say, for example, let's say let f of x equal x squared plus 5x. Okay. I want you guys to find f of -3. Take a moment to do that. Write down your work and then tell me what your answer is, your final answer, by just putting it in the chat. Okay, so just take a moment to do that. Anybody have the answer for it yet? I'm seeing in the chat -24. Do we have a consensus there? I put this parentheses -3 squared plus 5 times -3. I'm getting -6. Let me double check that.
Wait, Mr.
9 plus,
Willard,
yeah, I think it'd be -6. What's up?
wouldn't like -3 like squared? Wouldn't that just be 9? Because it's the exponent's 2, right? So it's 3 times 3, -9.
No,
Positive.
it would be -3 times -3, which is +9, plus 5 times -3, which is
-15.
-15. And so it should be -6.
Oh, okay.
Okay, but again, we don't have to do this extra work if you just put it into the calculator. Now, one reason that this might be wrong is if you guys put the first -3 and then you squared it without the parentheses, then you
Yeah.
made a critical error. Okay.
That's what I did.
You have to plug it in with the parentheses every single time, otherwise it's going to be mistaken. Okay?
Mhm.
Because if we had done this, then yeah, I could see why you would get the -24, but you forgot the first set of parentheses. And that's why I'm being very extra when I say you need to write it down with the parentheses, and then you need to type it into the calculator exactly how you wrote it down, parentheses and all. Okay? I'm not being extra for my benefit. I'm not going to make that mistake, right? I'm trying to prevent you guys from making that mistake. Okay? All right. So just be very careful with that when you're evaluating stuff in the calculator, but should be okay with a little bit of practice, and then a little bit of humility because, like, guys, I've been teaching this for 8 years. And it's the same questions over and over again because you guys are at the same level as my students from last year and the year before that, right? Um, you got to be a little bit humble if Alex is telling you that you've done something wrong, right? If it's telling you that you got the answer wrong, usually 99.9% of the time, you have done something wrong. And it could be like a tiny little formatting issue, or it could be a tiny little math issue. But like, do not have so much pride that you're going to yell at the computer and be like, I know I have this one right. Why does it keep telling me I'm wrong? It's because you're wrong. Okay. But that's okay. And I don't want you to beat your head into the desk. I want you to send me a screenshot of the problems that you're having and saying, hey, can you work this one out and let me know what I'm doing wrong? And then we can correct it. But you don't want to be one of these people out there that constantly thinks that they're right and everybody in the world is yelling at them and they don't care because God knows why, but we have far too many people of those people running around. Uh, so let's keep going on with our PowerPoint here so we can finish this up and then do a little bit of homework, get some practice. Okay. Um, let's see. Presentation again. So, like I said, these functions are machines. You can plug in x values and you can find their y values. But in other words, these things are, I like to tell all my students, I was raised Catholic. I'm not trying to force that on anybody. I'm not religious. But one thing that stuck with me is this idea that in Catholicism and Christianity, you think of God as being three things, the Holy Trinity, Father, Son, Holy Spirit. In this class, in algebra, we're going to think about functions as having three embodiments. Functions are a set of ordered pairs, they are equations, right? And they can also be represented by graphs. And we're going to have to move between those three representations and answer some questions and solve some problems. That being said, if I give you a function, you should be able to find its y-intercept because yesterday we had a definition that the y-intercept of any equation has an x value of 0. Okay? So if I give you a function and ask you to find its y-intercept, all you have to do is evaluate f of 0, where the 0 is the x value. Okay? Similarly, we have a definition for x-intercepts, where if we have an x-intercept, we need to set the y value to 0. So let's see what that looks like in the context of functions. So let's say I have this function here, and we'll switch over to pencil and paper because I think it'll make more sense. Let's write down q of x is equal to 3 over 4x minus 5. And the thing we want to do first is find the y-intercept. The reason why we want to find that y-intercept first is because it's easier than finding the x-intercept. Okay, so at the risk of disorienting you guys, I'm going to switch back over to my document camera. And we want to find the y-intercept. Recall the definition of the y-intercept. That is that the x value will be 0. Okay? So if we have an x value and we have a function, it should be simple enough to say, oh, just take that x value and plug it in for x. That's how we're going to find the y-intercept. Okay? So the way you would write that out with function notation is you would write q of 0 is equal to 3/4 times 0 minus 5. Okay? Any questions or comments about what I did or why I just wrote that down? Okay. Remember that once you have written q of 0, this was just like the instructions, right? We don't have to do anything else with this. It's not multiplying by 0, so get that out of your head. It's just telling us take the function q, which was this equation, and plug in a 0 for our x value, which is what we did. So now we just need to evaluate this. So can you guys tell me what 3/4 times 0 is?
0.
0. So what's my y-intercept?
-5.
It's just -5. So we know now that q of 0 is equal to -5, where, again, this is my x value, and this -5 is my y value. So I can say my y-intercept is at the location 0, comma, -5. Questions, comments? Does that seem too easy?
Sense.
Y-intercept is very easy to find. Okay. The x-intercept requires a little bit more work. So if that x-intercept exists, we'll say the x-intercept, by the definition, is y equals 0. But can you tell me, is there a y variable in this equation, in this function that we were given?
No.
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 And this is a tricky thing that it takes a while for a lot of students to understand, is that when we introduced function notation, we said f of x is equal to y, right? That was our function notation. Okay. So what that means is if I have q of x equals 3/4 x minus 5, then I can, if the function is the same thing as the y value, I can just replace this and write y equals 3/4 x minus 5. These are the same. So do I have a y value? Well, yeah.
5.
I'm just going to replace this q of x, or the y, with 0.
Oh.
Okay, and so I want you to be, I think where there might be some confusion here is that this is in slope-intercept form.
Mm.
And when I say, is there a y here? Can you find the y here? You might be thinking, oh, the y-intercept is -5. Well, we found that out from the last problem, but that's not what we're looking for. We're looking for the x-intercept. So for the x-intercept, we know that the y value is supposed to be 0 by definition. So what we're going to do here is replace this with 0 and then write our equation, 3/4x minus 5. Okay. So do you have to write all 3 of these lines every single time? No. You could just jump right into saying, okay, I'm just going to replace this whole side of the equation, the q of x, I'm going to replace that with 0, and then I'll solve for x. So now we're going to solve this equation for x. So how do I get this -5 over to the other side of the equation?
Add it to both sides.
So now we'll add it to both sides.
Okay.
Okay, so now we should have 5 is equal to 3/4 x. And then I don't want you to freak out because the calculator will take care of the fraction for us. How do I cancel out the 3/4? There's a couple of ways to do it.
Divide by,
Yeah, I was just gonna try to see if you guys needed a little reminder. It doesn't matter if this is a whole number or a fraction. We're gonna divide it to cancel it out and make sure you divide that on both sides. So anything divided by itself cancels out to 1, so this is just 1x left over. And then we're just gonna let the calculator do this division for us. Fractions are division problems. So if we have 5 on top, we're gonna put 5 divided by, and then we're going to put alpha y equals, enter, and then type in 3/4, right? That says 5 divided by 3/4. You hit enter, and what do we get?
20/3.
20/3. Is it the prettiest answer you've ever seen? Probably not, but it's a fully simplified fraction, and guess what? That's it. Okay? So we started with a y value of 0. We found our x value of 20/3. So if we put this as an ordered pair, the x value comes first, 20/3. The y value that we used was 0. So this over here is our x-intercept. Oh, there we go. Camera number 2, camera number 3. There we go. All right. Okay, so I want to stop there because I am going a little bit too long. There are a few more slides in the PowerPoint, but I want to give you guys an opportunity to work on some of the homework and ask some questions of your classmates. So what I'm going to ask you guys to do now here is to go over to Canvas. Let me go ahead and stop this share. Go over to Canvas and go to homework number, which one was it? I forget. I think it's 5, 4. Let's check it out. Go over to homework number 4. Assignment number 4 is functions and relations. Okay. I'm going to put you guys in the breakout rooms for probably about 20 minutes or so to work on those problems. Please help each other out, talk through some of the problems that you guys are having, and that'll be an opportunity for you guys to get some homework done during class. And then once that 20 minutes is over, we'll go ahead and return over here and then look at the next set of problems from the next PowerPoint, okay? So let me make those breakout rooms. And it's just going to be random, so let's see, how many people are there? If I do 3 breakout rooms, there's going to be 5 to 6 people per breakout room, so go ahead and accept this invitation. Okay. So this PowerPoint's called Algebra of Functions, and it's kind of involved a little bit. There's a lot of little examples that I have that I go over in the PowerPoint. Because we're going to introduce how do we work with multiple functions at the same time, okay? You're going to be asked to add, subtract, and multiply different functions, even divide them. And then there's also a new operation that, with numbers, we know how to add, subtract, multiply, and divide them, right? We've been learning that since grade school. But with functions, we can do something else because we really want to think of them as machines. And like in the real world, you could take 2 machines and put them together and get a new machine. Think of it like your cell phone. Back in the day, everybody just had a landline, but then eventually phones evolved where we said, okay, let's take a phone and let's add texting capabilities. Let's add an internet browser. Let's add music listening capabilities, right? So we added all of these new functions and new machines together to make a more complicated function. That's something that we can do with some of these functions that we're going to see. So we should know how to evaluate functions. That is, if I give you an x value, you're plugging them into the function and then figuring out what the y value is. So that's not going to be anything new. But what is new that you're going to see in this homework is where you're going to be given a graph and you're going to be told to evaluate the function as a graph. Okay? So what are we going to do here if we're told find f of 3 and then you have a graph like the one over here on the left? Okay. Well, what you have to realize is that you've been given every piece of information that you need. Okay. So first things that we need to identify. What are the graphs that they gave us and what are their names? So you're going to see these 2 charts and one of them is like a zigzag line that's colored blue. The other one is a zigzag line that's colored red. Those are your 2 functions. And they've labeled them f of x and g of x. Okay? So f of x is our blue function, right? G of x is the red function. So if I ask you, find f of 3, you might be struggling and thinking to yourself, well, okay, well, what do I need to multiply the 3 by? Well, there's nothing to multiply, okay? Because, first of all, the parentheses here doesn't mean multiplication. What does this 3 represent if it's inside the parentheses for the function?
X.
Yeah, it represents the x value. So x is equal to 3. So what this problem, even though it's not saying a whole lot, it's actually saying a lot. Okay, it's saying here's your x value. X is equal to 3. Now find the y value that belongs to the function f. Okay, so the way you want to approach this is I have put some dots on the x-axis. Okay, for this one, our x value is 3. So turn your attention to the dot that I put on the x-axis at 3. Okay, you're going to find that x value, and then you're going to go either straight up or straight down until you touch that function that they're interested in. So we're going to go up until we touch the function f of x. Okay, so that point that is now on the function f, can you guys tell me what is the ordered pair that describes that location? It's an x comma y. What's the x value?
3,
And what's the y value?
3.
3. Okay. Well, this problem is literally saying, okay, well, if your x value is 3, then what's the y value? 3. So guess what? Your answer for this one is 3 because that's what your y value was. And that's it. Questions, comments? Okay, we have some more examples coming. So if that feels like it's going too fast because it's so simple that it might be going over your head, here's some more practice. This one says, find f of negative 4. So what is the x value that they gave us here?
A -4.
So we're going to look at the x-axis and we're going to focus on negative 4. Then notice that at negative 4, if we were to go straight up, we would be touching the red function, which is g. But this problem is asking me to find f of negative 4, so I don't care about the function g. I want to go down until I touch the function f, and once I get there, I stop. Okay? So you could think about this as being the point -4, comma what? What's the y value?
-3.
-3.
Yeah, negative.
Yeah, because that's our y value right there, right? -3. Okay. So when it asks you for f of -4, what's the y value? It's -3. Questions, comments? Does that seem okay?
Yes.
Okay. So just be aware that they're going to give you multiple functions at the same time and you don't want to get turned around. They're always going to give you the function and then the x value. So here I need you guys to find g of 0. So we go to the x value of 0, and then where do we need to go to touch the function g? Up or down?
You can go up
You go straight up
to 4.
till we hit 4, and then we stop. And the y value is 4, so we can just say, oh, g of 0, that's equal to 4. Doesn't feel like math because we're not calculating anything, right? We're not putting anything into our calculator. We're not computing anything, but we're just looking up what's the y value. That's what it means to evaluate a function, whether it's an equation.
I think so.
I thought he was gonna come back up.
No, I thought he was having the screen troubles.
Sorry.
No.
Can you guys hear me?
Yeah.
Are you
Yes.
okay?
Yeah.
Was that a yes?
Yes.
Can you hear us?
Okay, my bad. I dropped out there for a second. In limbo. All right, let's get back to it. Sorry about the technical difficulties. One day I'll figure this out. All right, let's go ahead and share that PowerPoint again and get back into it. All right. So if I asked you guys to find g of 5, would you be able to find that, given what we just talked about?
Yes.
Yes.
What is it?
It would be -1.
5, negative.
It would be -1.
Mhm.
Yeah. Okay. So we're going to do some examples of function operations now because it's going to ask you to evaluate a bunch of functions and then do something with those y values, okay? So just remember what we're doing here is we're going to plug some numbers into some equations and get our output value. So when you add functions, you're really adding their y values, okay? When you subtract them, you need to find their y values and then subtract the y values, okay? So it should feel really simple, even though some of the equations that we look at maybe are going to be complicated. So this is where I said I really wanted to just jump into one of the homework problems in ALEKS to see if we can do that. So let's look at this one over here. So let me share this problem. And you guys see my screen okay?
Yes.
Yes.
Okay. So I'm going to write these down so that we can do them on paper because I think it'll make more sense. It says, given the functions, and it gives you more than one function. So we have f of x is equal to 3x. We have another function called g of x, and that is written as the absolute value of x plus 7. We haven't really touched on absolute value yet, but okay, we're going to have to learn as we go. And then we have h of x, which is equal to 1 over x minus 5. It looks a little bit intimidating, but remember, we can use the calculator to help us with those fraction problems. Okay? So I'm going to kind of ignore this problem as it's written right now. This one says to find f minus g of -2, but we don't really know what that symbol means yet. So let's just switch back over to pencil and paper so that we can be like in the real world here for a second. And then we'll see how we're going to type these answers into ALEKS. Okay? So we have these functions. What you're going to be asked to do is add, subtract, multiply, and divide functions. So I want to start with an example like, let's say we were given find f plus g of 0. Okay? It looks simple enough to be written like that, but you know, this is a foreign language. You're trying to decipher what these characters are telling you to do, and sometimes that can be hard because sometimes I still, even though I've told you guys once in this lecture that the parentheses here doesn't mean multiplication. I guarantee you that either later tonight or tomorrow, whenever you're working on these homework problems, you're going to say, oh, it's f plus g times 0. And it's not multiplication, okay? This is your x value, okay? So what this problem is really telling you to do is actually a few steps. What we want to do is find f of 0, which is going to be some y value. And then once we find that y value, we will add it to g of 0. So this input value is going to get plugged into both of these functions, and so we'll get two different y values, okay? So can you guys tell me, based on what I wrote here, right, I have my three functions, what is f of 0, or what do I need to write down here to figure that out?
3x.
Yeah, 3x, or 3 times 0, right? Because the function f says 3 times something. So 3 times 0 is equal to what?
0.
0. Okay? So now I found f of 0. Any questions about finding f of 0? Okay. The next step is we're going to take that 0 and plug it into g, right? But g is a different equation. So we have to look at the equation here, which says the absolute value of, we're going to plug in 0 plus 7, and then find the absolute value of that. Okay? Does anybody happen to know what the absolute value is? Okay. Well, the absolute value of a number is just its distance from 0. So usually when we measure distances, if you think about this like in the real world, you might just pull out a measuring tape and say, okay, if I threw a rock, I'd say the rock is 3 feet from me, right? But if I picked up that rock and I threw it to my right and I measured it, it's 3 feet away. If I placed that rock 3 feet to my left and I measured it with a measuring tape, what does my measuring tape say? Well, did the measuring tape magically generate negative numbers?
No.
No, the measuring tape always has positive values, right? So we always measure distances as positive values. So if I have, for instance, the absolute value.
Yeah. Are you okay?
Let me see if we can.
Yes. Yes. Can you hear us? Okay.
Anybody in the background need to turn off their audio? There we go. All right. So again, if I ask you what's the absolute value of 5, if you had a rock that was 5 feet away from you, you would just say, oh, that's just 5. And if I had the absolute value of -5, the measuring tape doesn't magically give you negative distances. Measuring tape stays positive, so that's going to be 5 as well. Okay. So the absolute value of 0 plus 7 is just 7. Okay. So that's my second y value, right? Now, if you need to Google or just YouTube absolute value, I'm sure that you can find a little lesson on that. But what we needed to be able to do here is evaluate f of 0 and then g of 0. And then this problem is just telling us add those numbers together. What's 0 plus 7?
7.
That's your answer. That's your final answer. Okay. So what you're doing is you're plugging that x value into the functions that they tell you. In this case, it was f plus g. And then whenever you get those two numbers evaluated, you do the operation that it's asking, which in this case was addition. Okay. So now we're going to use those same functions, but this time I'm going to ask you to find f minus h of 3. So I'll put 1 here and 2 here. This is a second problem, okay? So when you set this up, you want to kind of translate this into some instructions for yourself. What does this 3 represent?
The x value.
The x value. Okay, so just remind yourself, you're not multiplying anything times 3. That's not what we're doing here. We're taking that x value, and what we need to do is plug that 3 into the function f, and then subtract what we get whenever we take that 3 and plug it into the function h. Okay, so what was the function f here? And remember, we're dealing with these 3 functions up here.
3 times 3.
Yeah, so this one's going to be 3 times 3, which is what?
9.
9. Great. Minus, now we need to find h of 3. Okay, so what's the function h?
One over x minus 5.
Yeah, 1 over x minus 5. So what we're going to do is 1 over 3 minus 5.
5.
And again, how are we going to evaluate that one?
Put it in the
Put it
calculator.
in the
Put it in
calculator.
the calculator, guys. All right, so we're going to do
Negative.
alpha y equals, enter, and then we can type 1 over 3 minus 5, and I got negative 1/2. You guys okay with that? Questions? Okay, so when I evaluated that, be very careful. I have a negative answer, and I'm subtracting. Do I need both of those negative signs? The answer is yes. I need to put this as parentheses negative 1/2 here. Because I'm subtracting negative 1/2. I'm subtracting the value that I found. Okay. So I worked with a student earlier today, and the only reason I'm being extra is because they said, oh, but my answer was a negative. So do I have to put another negative? Yes, because they're saying you have to subtract whatever number you got here, and we just happen to have gotten a negative. So we need both of those negatives. But in any case, you can throw 9 minus negative 1/2 in the calculator exactly the way we wrote it. 9 minus, and then we can put parentheses, make that fraction, negative 1 over 2. Or you can put the negative in the front. It doesn't make a difference. Put that negative in the front and not on top. Either way, you get 19 over 2. That's your answer. Questions, comments, concerns? Another thing that I noticed is that some students that I'm working with in person, they're really resistant to writing any of their work down, right? And so if you're one of these students that's like you're staring at the computer screen and you're thinking like I should be able to do this in my head, you're wrong. You should not be able to do this in your head. There's too many steps. That's why you need to write this stuff down, okay? And another reason is because as you write it down, you're committing it to memory. You're learning the habit to get into, and that's going to help you remember, okay, what's step 1? What's step 2? What's step 3? So on and so forth. Okay. You're building that muscle memory. Okay. Because it's not the case that I'm going to go to the gym and then I'm just going to watch somebody work out and then I'm somehow going to get shredded. Like, that's not how that works. You have to jump in there and do the work. Okay.
I wish.
Yeah, if only.
Yeah.
Okay. So I'm going to use these equations again. So we've done addition of functions. We've done subtraction of functions. We have 2 more operations, which are multiplication and division. Okay. So let me rewrite these functions so that we have them. We have f of x, which was equal to 3x. We had g of x, which was the absolute value of x plus 7. There we go. Absolute value. Be very absolute about it. And then we have h of x, which was 1 over x. Was it minus 5? Minus 5.
Fine.
Okay. So we want a multiplication problem. Okay, the way this is going to look is Alex is going to tell you something.
Quick question.
Yeah, go
How
ahead.
come you're putting that one in red? What's different about that one?
Oh, yeah. The only reason I'm putting it in red is I put this one in black, this one in blue, and this one in red, just so that visually you can see that they're 3 different functions.
Oh, okay. I thought the red meant something different. I
No,
didn't see it that way.
red doesn't mean it's bad. Although I
Okay.
think subconsciously I put it in red because it's a fraction, and I know you guys will think that's harder.
Perfect. Yeah.
Okay.
I
So
feel
let's do this. Let's do g times h of negative 5. Okay. Remember, if you have g and h just next to each other, that implies multiplication. Sometimes they put a dot between them. Sorry, that's g times g. G times h is equal to gh. Okay. But this means multiplication. I'm just going to put multiply because I've run out of space there. All right, so what are we doing here? You always have to remember or ask yourself, What is this -5 again? Am I multiplying a -5?
No.
No. What is this -5 and I just gave it away?
X value.
X.
That's my X value, right? So that's the number I'm going to plug into each of these functions. So I'm going to go over here, maybe do some scratch work. I'm going to say equals G, which let me keep my color coordination. G is the blue function. G of -5. And then whatever I get from there, I'm going to multiply that with H of -5. And so we want to tackle these separately, right? How do I evaluate G of -5? What are these bars called again?
Absolute value.
Absolute value.
Absolute value. So we're going to take the absolute value of -5 plus 7. Okay, and if you didn't like my explanation of what absolute value means, that's perfectly fine. Guess what? There's a way to do it in the calculator.
Amazing.
Okay. If you press the math button and you go over to the right to where it says number, ABS, guess what? That means absolute value. So again, math button, go to the right, that ABS function gives you those vertical bars. That's absolute value. Okay, and this is going to be in the recording, all right? In case you forget. So we can just type -5 plus 7 in the absolute value bars, hit enter, and that's our answer too. So we got 2 here, and we need to multiply that by whatever we get when we evaluate H of -5. This one's more complicated, so I'm going to write it down as 1 over -5 minus 5. And then how are we going to evaluate that one? In the calculator. 1 over -5 minus 5. You should be getting -1/10. And I'm just putting it in parentheses just to be extra. You don't have to put it in parentheses. But now we're just going to do 2 times that fraction that we just got, -1 over 10. And it should become -1/5. And that's our answer. Right? So we have to evaluate each of these functions, and then our y values, or the outputs of each of those, we're going to multiply them because that's what this operation says. Okay. 4 is division. So in this case, you might have a problem that says like, what if we did f divided by g of 2? So similar to those last problems, we just need to set this up as a division problem. So I'm going to write it as a fraction. So I hope you guys don't mind me writing it as a fraction. There's our fraction. F of 2 goes on top, and g of 2 goes on the bottom. So I need to be able to evaluate that fraction. F of 2 is going to be 3 times 2, because our function was 3x.
Mhm.
And g of 2 is going to be the absolute value of 2 plus 7, like so. Now, you could simplify this, the top and then the bottom separately, or you could throw this whole thing into the calculator because we know how to make fractions and we know how to use the absolute value bars now. So if you want to do it all at once, you can totally do that. We could set up our fraction, put 3 times 2 on top. On the bottom, we can hit that math button, go over to the side to get the absolute value function, put 2 plus 7 in the absolute value bars, and then let the calculator do all the work for you. It's 2/3. Okay. And that's our final answer. Okay. Now, I said that there is one more operation that we can do here with functions that you can't do with numbers. Okay. And that is something that looks like this. It's called function composition. I'm going to do f composed with h. And we'll do like 1. Okay. So if you see this open circle, that is composition. Okay.
Question.
And
When
yeah,
we
what's
see
up?
that open circle, will it be like in bold or something so we don't think it's a 0?
Usually it does look kind of bold, but I can't guarantee that. But you know, you're never going to have like a number just wedged between those letters. That's not something that you see in math. Um, so when you see this open circle and not a dot, then it's going to be composition.
Would it be the the little one on top of the number 3 on our calculator?
On top of the 3? No,
The
it's not that. It's not that. Actually,
Oh.
you can't do this in the
Oh, you just said
calculator.
you can't do it in the calculator. Sorry.
Yeah, you can't do this in the calculator the same way you do addition, subtraction, multiplication, and division. Okay, it's not a routine operation. This composition is sometimes written alternatively like this, where they will say, okay, I'm gonna write h of 1, and then inside of that's gonna be inside of f. These two things both mean composition. Okay, and what is composition? Okay, so composition is basically the simplest analogy I can give you is that you guys know how to do your laundry, I would assume, because we're all adults. Okay, in the laundry process, you take clothes, right? Your dirty clothes, and that's the input that you put into a machine, right? You put it into the washing machine. And then what's the output once you take it out of the washer? What do you have? Do you still have dirty clothes?
No, they're clean.
Clean wet.
You have clean, wet clothes.
Yeah.
Okay, now if we lived in el campo and el rancho, then you would go ahead and hang up your wet clothes outside and it would dry on its own and you'd be done with the laundry, right? But like in a modern household, you have another machine, right? So you take the output of the washer and you put it into another machine so that it can do its job, and then you get some final output. Does that make sense?
Yes.
So that's what composition is doing. It's saying, here's an x value. We're going to take that x value, and the first step is we're going to find h of 1. Okay? So that's like doing our wash. We're going to take h of 1. In other words, if you see it like this, you're doing the inside stuff first. So we can do h of 1. We've been evaluating these functions. H of 1 is going to be equal to 1 over 1 minus 5, which, to save you some heartache, I'll go ahead and just evaluate that in my head. 1 minus 5 is negative 4. So that's going to be 1/4, but that's going to be a negative. If you put it in the calculator, you'll see that you get negative 1/4. Okay, but that was like we took our dirty clothes and we put it through the wash. Are we done with laundry?
No.
No. So the next step, step 2, is to take that negative 1/4 as the new input, and we're going to plug that into the function f, or that function that's on the outside. So we're going to find f of negative 1/4 now. Okay, so we're taking the wash and putting it into the next machine in the cycle, which is the dryer. Well, the function f is just 3 times x. So we're going to do 3 times negative 1/4. And if you put that in your calculator, you should get negative 3/4. And since we put our dirty clothes into the wash, we took our wet clothes and put it into the dryer. Once the dryer is done, we're done with the laundry. That's your final answer. So you have to watch out for this new symbol of composition because it's a little bit more complicated of a process where we're going to take an input, that x value, put it into one function, and then we're going to get that output and put it into the next function. So I kind of went over 5 minutes there, so I don't want to keep you guys, but if you have any questions and want to hang back, then feel free to do so. Otherwise, I'm going to post an announcement in Canvas to let you guys know what you need to do over the weekend. There will be some homework over the weekend. I already made some videos for you so that you can finish up that last homework assignment in Module 1. Okay?